So this question, we have a series of graphs. So we will begin with analyzing those graphs before we read the question. So we look for the origins, and at all of these, the origins are 0, 0. So we're okay there. The y-axis for all of them, the vertical axis is speed. X-axis for all of them is time. The intercepts in this case, the y-intercept will be v0. So we're looking for v0 for the intercepts, and read is velocity time gradient. Dividing the axes is delta v over delta t. That is the acceleration. And the area is v times delta t, which is the displacement. Meters per second times seconds gives us the displacement. So now we read the question. We've got a steel sphere dropped from rest in oil. So here's our oil. We drop the sphere, and so it's going to free fall. The velocity is going to increase. We are told it starts from rest, so v0 equals 0. And v0, that's the intercept. So we'll look at the intercepts, and we'll see v is 0, v0, 0, 0, 0, 0, 0. So that doesn't help us discriminate from among those choices. So the velocity is going to increase. It's starting at 0. It's going to reach terminal velocity. And when it reaches terminal velocity, the velocity will be constant. And if it reaches terminal velocity, that means the acceleration is 0. So the gradient would be 0. So if we look for choices that have a gradient equal to 0, we look, that's A, that's B. So this area and this area have a 0 slope. But this one definitely does not, and neither does this. So that gets us down to two choices, A and B. And the difference there is that choice A, the change is gradual, whereas in B, it's abrupt. So all of a sudden, it just stops accelerating. Well, we know it's a gradual shift, so that is choice A.